In this video, I summarize the proof of this cosine of s plus t. Once again, it's a shorter version. It's a more better for a test version, but detailed version of the proof and all the other cases are found in the earlier video. This is a shorter version. The general proof could be, you have to think about all the possibilities of s and t's, but here in this proof, we're only going to show this result for s is small enough between 0 and pi over 2, and t also between 0 and pi over 2, such that when you add these angles together, it doesn't go beyond 180 degree or pi. So with this much of restriction, still it's meaningful to see how this one plays out. So I'll make this as a part of a proof. If you look at the statement, before you prove it, look at the statement and remember how the setup goes. The setup is the following. Remember this part, we're going to sketch the angle S and angle T, because the formula is break this one down, and S plus T. But it turns out, and just paying attention to the angle negative T is actually very useful. So this is the part that you have to remember looking at the formula. What we're going to sketch is sketch angle S and negative T and angle S plus T. If you sketch these three angles and label x and y coordinates, everything else is pretty much an algebraic work. So here's the circle. It's actually a unit circle, so I want to write this one down. X squared plus y squared equals 1. So we'll see, look at many points in here. All of them satisfy these Cartesian equations. The first one will be this point. Down there, this point, P0, we can label P0 as 1 comma 0. And we're going to sketch S and S plus T here. S is going to be this small angle, just pretend here. This is angle S. We're going to label it P1, X1, and Y1. And T is going to be another small angle like that. So this is a T, not the whole thing. This whole thing is actually angle S plus T. So this terminal point, P2, X2, Y2, these coordinates are related with the angle S plus T, not just the T here. So that's the sketch of S and S plus T, and you have to sketch that negative T. So negative T is just about this much. So negative is this direction. Here's a negative T. And we're going to label this point all the way down here as P3 with X3, Y3. So this is the setup you need to memorize a little bit. And this, of course, this might have took a long time for them to discover this neat setup so that the proof folds out nicely and cleanly. But this is a setup, sketch S and S plus T and negative T and label it like this. And next thing is that you have to associate all these points in here with the angle. So let's think about this one here. This point is associated with this angle S plus T. If you look at it, this is the terminal point of this angle S plus T. This point here is associated with this angle S. And this one is going to be just a 0. Think about what is the angle that is associated here. That's exactly negative T here. So all the x-coordinate, y-coordinates of these 3 points is written in terms of cosine and sine of this angle, and then that angle. And this is the setup you need to get used to. And the rest of the part is writing out the trigonometry and computing different stuff. So that's the setup. And second one is an observation. You can simply write down the observation using this picture or in words, it doesn't matter. But the first observation is this triangle in here, that O is the center O, and this horizontal line here, this is a P0, that is this point. And we look at this P2, their clever argument. I'm going to label it X2, Y2, and this one we know what it is 1 comma 0. And think about what this angle here is. This angle, if you look at it as a positive measure, you go S unit, S radian, and T radian, so that must be S plus T radian. And this side's OP2 and OP0 is the radius of this circle. Therefore, it's a unit circle, so therefore it must be 1 and 1 there. So this is a triangle. We're going to label this one D. If you look at the second triangle that has a similar shape, it looks like this. Down there. This is O. That point here is P1. And make a triangle. That point down there is a P3. Although this angle here is labeled negative T, if you want to measure this angle, you start from here and going clockwise or with a different initial side. Therefore, this would be positive measure T, and that go another S. So it's a positive T, clockwise, counterclockwise rotation, and counterclockwise rotation S radian. So altogether, this is also S plus T radian. And if it's a bit confusing because of this notation, then you can actually look at some example like a 20 degree here, negative 30 degree, and think about what will be this entire angle. That would be obviously 50 degree. So we're going to label this x1, y1, and x3 and y3 is down there. Don't think it's a reflection or anything. It's just an arbitrary picture. You can imagine an S can be very small and T can be a little bit wider. It's nothing to do with these two things are reflection to each other or anything. So if you look at these two things, and I'm going to label this one an L because this came from also the radius of the circle. So these two sides are 1, 1, and angle subtended by these two sides is S plus T here and S plus T there. So these two sides and angle in between makes these two triangle congruent to each other. I hope I spell it correctly. That means all the sides and angles are the same, not just the angles. So that makes this D equals L. So this observation, this side in here, D, and that side in there, L, came from the same subtended angle being equal, connects all these x-coordinate and y-coordinates. Connecting x-coordinate and y-coordinate here is the same as connecting cosine and sine values of S plus T with cosine and sine values of S and T. So that kind of makes sense. That's the plan. So this much of observation. Conclusion is this one. You can easily write down S plus T and S plus T there. It's kind of same angle. Therefore, we intuitively, this is easily, you can claim that this follows easily. But I wanted to draw this triangle to clearly see why they're equal. From here, what you have to remember, so you remember this D and L is going to be equal to each other. Next direction is that, so what are we going to do with this property that D and L are equal to each other? We're going to, from here, we're going to use this distance formula. So it's a really powerful idea to think about all this geometry and geometry within that xy coordinate, and algebra is actually pretty powerful. So computing this, the length of these two D and L, is not going to be using any trigonometry or anything about S plus T. Just look at these coordinates and apply the distance formula. That's what I wrote in here. So set up and conclude D's in, and D and D is equal to L. You must have to explain what this D and L are. Then think about the next direction is distance formula. So here's distance formula. First, well, distance formula, you know it involves square root. So instead of considering D, we're going to look at D squared. So distance formula of this one in here, it's not quite showing. So I'm going to put this one down in here. Now it's showing. Sorry about that. So D is this length, and apply the distance formula to that without square root. So that would be x2 minus 1 squared. That's the x-coordinate here. And y-coordinate is y2. That's y-coordinate of that point, and the other point is 0 minus 0 squared. So that's how the distance formula works for these 2 points. And let's look at L. Look at L here, L squared. And L is this distance of these 2 points, and they have these coordinates. So x1 is one x-coordinate, and x3 is the other x-coordinate. y1 and y3 here is y1 and minus y3. That's a squared. All right, So we have these two things, a d squared and l squared. Of course, they're equal to each other. They're written in terms of coordinates, and all these coordinates is written in terms of trigonometric values of these angles. So let's do some algebra. You have to expand those and use this binomial theorem, a plus b squared equals a squared plus 2ab plus b squared, right? If you apply this binomial expansion theorem to each of the square term, you'll be able to compute all these things. So why don't you pause the video and practice yourself and do all this part and yourself and see you get what I have in here. Okay, this is what I got. If you expand this each of the term, this one is particularly easy. Then since there's no term in here, it's y2 squared, and because the middle term is all negative, you got to have this negative everywhere. So to take a moment and see if you get all the terms exactly like this. This is what I got. Now a lot of things are simplified here, especially all the square terms. So if you have the same pair x2 squared and y2 squared, because they're on the unit circle, they're always 1. So for example, if you look at the first line, you can easily see there's x2 squared and there's y2 squared. So they came from this point right there, therefore that value is just simply positive 1. You can find those pair again. I have x1 squared here. So x1 squared is on the unit circle. y1 squared is over here. And x3 squared showed up here, and x3 squared in a quick line. y3 squared showed up in here. So if you combine them together, they're always 1. So there's already 1 here. So the first one will be 2 minus 2x2. So I'm going to write it down here. So let us have more room here just to do that algebra part. So here our d squared, this part is now simply, this part is 1. So together with that one is going to be 2 minus 2x2. Now l squared, and if you combine these two, you get 1. This squiggly part, get another 1, so altogether is 2 again. So it's a 2 minus the rest of the part. It's minus 2x1, x3, minus 2y1, y3. So this simplified pretty a lot because of those sum of the square being 1. And next thing is using this property that d is equal to L. Therefore, if you subtract these two, the left-hand side is going to be 0. We're subtracting the second line from the first line. That makes this one 0 as well. But there's no negative 2x2, so I'm going to keep it here. And this one is subtracted from the first line, so that all changed the sign to 2x3, negative, positive 2y1, y3 like that. Okay, so this is x2, and all the other things are coming from point 1 and point 3, point 1 and point 3. So let me show you point 2 and point 1 and point 3 situation. So here's a point 2 and point 1 and point 3 out here. So point 2 is associated with this angle s plus t. Point 1 and point 3 are the cosine and sine value of s and t. So we want to have cosine of s plus t on the one side, and that came from the second point. Right, that's why we want to isolate this one, come from second point, from s plus t. So I'll move it over here on that side. 2 of x2 is a positive, and 2x1, 2x3, plus 2y1, 2y3. Now everywhere there's a t, so you can cancel those t2's like this. Then we have this property. All you have to do now is figure out this cosine trigonometric value of x2 and all these x and y coordinate. They are all on the unit circle, so they can relate it to the values of the cosine and values of the sine. Okay, so I brought this one up here. I hope it's not too small, as you can see. So x2 came from the second point here, is about this angle s plus t. So x2, that was in the left-hand side. It's now look like x-coordinate of that angle. So it's going to be cosine of s plus t. That's the unit circle. And x1 here, x1 is this point associated with this angle s and x-coordinate, so it's a cosine s. And the second term is x3. So x-coordinate must be cosine, but 3's are coming from negative t, so that's a cosine negative t there. So next part, next terms y1 and y3. y1, first point, angle s, so that's the sine s. And the third point is angle negative t, so it's a y3 is the sine of negative t. Now here we can use even and odd properties that you can see this is the same, this part here is the same as cosine t, and that part is a negative sine t because sine is odd function. Now we're almost over. These x2 on the left hand side, which was cosine s plus t, that was this part in here. x1 and x3 identified it here because of the even property of this function cosine negative t, that becomes cosine s times cosine t. And y1, y3, y1 is a sine s times y3 is a parenthesis sine negative t, but you can pull out the negative outside in here and put that sine t there. So we are able to rewrite this, all this x and y coordinate in terms of the values of the cosine and cosine that correspond to each of these angles there. So if you look at this one and you realize that we have proved the addition formula of this cosine in here. Like I said, all the other cases, even including s being larger than the 2 pi, pi over 2, and so on, they're actually introduced nicely in the other video, but just the proof of the short part, and for the test version of the proof, I think this is sufficient. Thank you.